Good morning friends. Today we are going to study our fifth chapter, that is oscillation. In this chapter we have to study the composition of two SHM. When two SHM are crosses, then we get the third, what we get, that we have to find. Okay? The composition of two SHM having the same period but having different amplitude and different phase angle. Therefore, now we have to consider the two SHM, that is x1 equation of displacement of two SHM. Therefore, x1 is equal to a1 sin omega t plus phi. This is the equation of displacement of first SHM, and x2 is equal to a2 sin omega t plus phi. This is the equation of displacement of second SHM. Therefore, composition of two SHM, this two SHM, we get x is equal to x1 plus x2. Therefore, x is equal to, adding this x1 and x2, we get a1 sin omega t plus phi plus a2 sin omega t plus phi. Okay? Therefore, x is equal to a1 using the formula sin a plus b. Sin a plus b is sin a cos b plus cos a sin b. Therefore, sin omega t cos phi plus cos omega t sin phi plus a2 using same formula for this sin omega t plus phi 2 sin omega t cos phi 2 plus cos omega t plus sin phi. Here a1, a2 are constant. Therefore, sin omega t and cos omega t, these are also constant. Therefore, taking constant one side, x is equal to a1. Multiplying this a1, we get sin omega t cos phi 1 plus a1 sin phi 1 cos omega t plus a2 sin omega t cos phi 2 plus a2 sin phi 2 cos omega t. Here, adding these two, we get taking sin omega t constant, sin omega t a1 cos phi 1, a2 cos phi 1. Plus taking this omega t constant, cos omega t a1 sin sin phi 1 plus a2 sin phi. Okay. Here we use some another constant. Therefore, substitute r sin delta is equal to a1 sin phi 1 plus a2 sin phi 2 and r cos delta is equal to a2 cos phi 1 plus a2 cos phi 2. Substituting these two values in this equation, we get sin omega t r cos delta plus cos omega t into r sin delta. Taking r constant outside common, sin omega t cos delta plus cos omega t sin delta. We get r is equal to r in bracket sin omega t plus delta. Therefore, here x is equal to r sin omega t plus delta. This is the equation of composition of 2SHM. After composition of 2SHM, we get the third SHM. This is the equation of that third simple harmonic motion. म्हणजे दोन सिंपल हार्मोनिक मोशनचं जर कॉम्पोजिशन केलं तर त्याच्यापासून मिळणारे हे जे तिसरं इक्वेशन जे मिळते दॅट इज ऑल्सो इक्वेशन ऑफ कॉम्पोजिशन, इक्वेशन ऑफ SHM. We have to find the value of this resultant r and this phase angle delta. For finding the value of r, squaring and adding these two equations, we get r square sin square delta plus r square cos square delta is equal to squaring and adding. We get a1 sin phi a square sin phi 1 square plus a2 square sin phi 2 square plus 2a1 a2 sin phi 1 sin phi plus a1 square plus a1 square cos phi 1 square plus a2 square cos phi 2 square plus 2a1 a2 cos phi 1 cos phi. And these two equations we get r square which is equal to, adding these two equations we get a1 square sin phi 1 square plus cos phi 1 square is 1 plus adding these two we get a2 square sin phi 2 square plus cos phi 2 square is 1 plus from these two take common 2a1 a2 here sin phi 1 sin phi 2 plus cos phi 1 cos phi. Okay, therefore r square is equal to a1 square a2 square plus 2a1 a2. This is the formula for cos of phi 1 minus phi. Therefore r is equal to under root a1 square plus a2 square plus 2a1 a2 cos phi 1 minus. This is the equation of resultant amplitude. Now we have to find the equation for phase angle delta. For this, dividing equation 1, dividing this equation by this second equation, we get r sin delta divided by r cos delta is equal to a1 sin phi 1 plus a2 sin phi 2 divided by a1 cos phi 1 plus a2 cos phi. This r will cancel. Therefore, tan delta is equal to same as a1 sin phi 1 plus a2 sin phi 2 a1 cos phi 1 plus a2 cos phi 2. Therefore, angle delta is equal to tan inverse of this equation a1 sin phi 1 plus a2 sin phi 2 divided by a1 cos phi 1 plus a2 cos phi. Therefore, we get the two equations. Therefore, this is the resultant amplitude and this is resultant phase angle. Okay. Now we have to study three cases. First one, if phase difference phi 1 minus phi 2 is equal to 0, that is if phi 1 minus phi 2 is equal to 0, then this equation of resultant amplitude is equal to r. Taking here, we substitute the value of phi 1 minus phi 2 is equal to 0. Therefore, cos 0 is equal to 1. Cos of phi 1 minus phi 2 is equal to 1. Then, here a1 square plus a2 square plus 2a1 a2. Therefore, r is equal to a1 plus a2. Now, second case, if phi 1 minus phi 2 is equal to 90 degree. If phi 1 minus phi 2 is equal to 90 degree, therefore cos of phi 1 minus phi 2 is equal to 0. That is cos 90 is equal to 0. Therefore, this equation r is equal to a1 square plus a2 square plus 0. Therefore, r is equal to under root a1 square plus a2 square. Third case is if this phi 1 minus phi 2 is 180, phi 1 minus phi 2 is equal to 180 degree. Therefore, cos of 180 is equal to minus 1. Therefore, this is equation of resultant amplitude r is equal to under root a1 square plus a2 square minus 2 a1 a2. Therefore, r is equal to a1 minus a2. Okay. This is the three cases of amplitude. अशा पद्धतीने आपल्याला amplitude of resultant amplitude of composition of 2 SHM आणि ह्या त्याच्या तीन केसेस आहेत ज्याच्यामध्ये r is equal to आपल्याला मिळालं addition of amplitude of both the SHM. Second one, squaring and adding taking square root. Third one is subtraction of 2 SHM.